That's impressive. But let's talk about this math. Guys, we need to remember that the reason we go over homework is so that you can get your questions answered. It is by understanding what you made mistakes on that you get better. Say again, sir.
What's no door mean? No door?
Common difference
Or ratio?
or common ratio.
But Simon and I spelled door.
I know, I was like, you're a bit of a dork, but that's a whole different thing.
How? I would agree.
So, what questions do you have about why it was neither for 9 or 11, or why it was exponential for number 10?
Too long.
No questions at all. What about it? Why is it exponential? So I know this looks very different than most exponential that we've seen before, but what I would remind you of is in the past we've seen exponential that look like this, right? So it's just been translated up and then it's been reflected to go down. But you see how it has that same exact curve to it? Does that make sense, Mona? And so that's something to be aware of, and we'll explore this more heavily, these ideas of transformations. We'll look at them later this year. But y'all have seen that in Algebra 1 and in geometry before. But that's all that happened. It was a translation up, and then, actually it was a vertical reflection, then a translation up that caused that. So I will say it looks a little bit different, but it is still an exponential curve there. Any other questions about 9 or 11 before we move on?
No.
Okay. So, did you just find it?
Yes.
Okay, so notice you are checking for accuracy. You need to check those 3 very quickly. While Cheyenne is checking those 3, really quick note, I did already grade your, no what?
Oh no.
Okay, I already did grade your understanding checks from yesterday. Alan, that's something you need to make up over the next day or so if you can.
I need an excuse in.
Yeah, well, I mean, I'll let you make it up before the excuse comes in, because I'm going to be giving them back in the next day or two. If you haven't taken it by the time I give it back, then that means that, well, you'll just have to take a 0 until you take the test, and then whatever you make on the test will replace that grade. But I'd rather you go ahead and take it so that you can get feedback and learn how to improve those skills. What I will say is, in grading it, there are definitely some details that I'm realizing most of us have misunderstood or forgotten about sequences. That was like that second half there. So we need to review discrete continuous, especially for those of you who were absent. I will say the people who were consistently here through 2.1 and 2.2, they actually did very well on the first 5 or 6 questions that were about whether it was discrete or continuous. And then the second half they did pretty well as well. But for those of y'all that were gone, it was clear that we had not worked through the lessons that I've been posting on Schoology or watched any of the videos. Just because you're not here doesn't mean you shouldn't do anything. It's going to bite you in the butt if you come back and just expect me to reteach everything. There's a reason why I uploaded those videos so that you can learn from the discussions that we've had in class. You got to do the work even when you're not here. And I know it's a pain in the butt. When we missed because of COVID and things like that, or where we didn't even have it, just we got exposed to it, whatever. But it's the world that we live in, unfortunately. So we've got to make the best out of a bad situation. Make sure you're doing your work. There was something else I was going to say. I don't remember. Oh, the arithmetic and geometric means, those last 2 questions, we got to work on it. A lot.
Yep.
Okay. Numbers 15 and 16. These are geometric means. Hopefully we knew how to do these. Now as a reminder, each of these questions is worth 15%. Or 14%, sorry. So, please notice if every question is 14%, but I have 1, 2, 3, 4 things there. Actually, does it ask you to identify the common ratio or just fill in the table?
Fill in the table.
I don't know, but I got that right.
Fill
Just
in
says find the missing terms? Okay. So we don't have to do this 4th part. But those are 3, so you're gonna take your 14%, split it over 3 questions, and so each of those pieces in the table would be 4%. Okay. So give yourself the credit if you earned it.
Wait, how do you give yourself credit? Like add a plus?
So like that.
So I gotta do -4.
Nope. You just
I've
put
never
a
done
plus
that
0.
before.
Just count up how many. Well, then like notice it's 4% per part here. So if you want to, if you got all of them right, just plus 12. Let's say you got 2 of them right, it'd be plus 8.
Oh my god.
But you're supposed to indicate how much you got correct there.
I got the answer.
I didn't ever do that before.
We're supposed to do that for the last one too.
What do you mean?
Also, the last
Yes.
one for 8, 9, 10.
Yeah. Well, 9, 10, 11. Put a plus 0 or a plus 14. Right? You don't take away stuff. It's just plus 0 or plus 14. Because either you got the points or you didn't.
14.
Okay? And I think it just asks you to find the slope or the rate of change here, doesn't it? So both of these are 14%. What questions do you have off of these 4?
Yeah, none.
None?
None.
None?
How much is this homework grade count for?
There'll be 5 points. It's 100%. Let me make this quick note though. What was it? 7 questions, 98. So
5 points for your overall.
add 6%. Whatever. Add up all your points and then add 6% to it.
I got 20.
So add up all the points you earned and then add 6% to it.
I forgot how to add. How do you add?
There's a thing called a calculator.
I forgot how to use it.
I guess you get a 0 then.
Mm-mm.
Well, then add up your points.
Remember that show called Puppy? It's called Puppy.
Alright, any questions before we move on? Going once? Going twice?
So,
I am about to say sold and I'm not coming back to it. However, I want to point this out. 15 and 16 were geometric means. We struggled on these on the test, or on the quiz yesterday. We struggled on them the first time, but magically all of a sudden no one has a single question about these 2 tables. How does that make sense?
I honestly think I left one of them
I'll get
blank.
you a question. How do you do a arithmetic thing?
Instead of a geometric?
Yeah, 'cause that's what got me on the
Okay.
That's my head.
So, I'm going to use number 16 to answer that question. Sound good? First off, how would you answer 16 if it was geometric, or since it's geometric? How did I get my r as 3 or negative 3? Okay, so you can do that, which gives you 81. But then how did I get the 3 from that? So that is a part of the common ratio. I'm going to come back to this in a second. However, this is the way that you're going to have to memorize things if you try to approach it this way. What I would personally do is I would say, hey, what number am I starting at?
3.
Not 3.
1.
Negative 3. Okay. Now, once I figure it out, I know what my common ratio is. But to start the problem, do I know what this common ratio is? No. How many common ratios do I have, though?
4.
4. And with a common ratio, you're repeatedly...
Multiply.
by 4.
So I'm multiplying by r. And what would I do to show that I'm repeatedly multiplying by r 4 times?
Very exponential.
Well, notice the variable's here. I know how many times I'm multiplying by r. It's 4 times. After I start at negative 3 and I multiply by r 4 times, what do I get to? So that equals negative 243. Notice what would be my first step to solve this equation?
Take divided by -3.
Isn't that the negative 243 divided by negative 3 that we had right here? So that's going to equal 81. Now what would I do to solve this equation?
Square root. Quad squared.
Not a square root.
Quad
Fourth root. Now, the fourth root, the square root, all the even roots are those cases where you can have positive or negative, but if you do a fourth root of 81, you get a plus or minus 3. That's it. Once I know my common ratio, I can fill in those terms pretty easily. But your question was, how do we do it for an arithmetic sequence, right? If it's arithmetic, I'm not repeatedly multiplying, I'm repeatedly adding. But still, what am I starting at?
3.
Negative 3. Then, you just said I'm repeatedly adding, right? Do we know what we're repeatedly adding by? Well, R is a common ratio. What do we call an additive rate of change? Common difference. So I'm adding by D. How would I show the fact that I'm repeatedly adding? How many times am I adding my common difference? So I'm going to multiply by 4. After I add my common difference 4 times, what number do I get to? Can I solve this equation exactly the same way? Except here I was trying to create the number 1 because I'm adding and subtracting. I'm going to try to create the number 0. So I'm going to add 3. And so that's a 0 now. So 4D is equal to negative 240. Now I'm creating that 1. The common difference is negative 60. This is why I write out these equations instead of just trying to memorize the formula or the process, right? If you write out that equation, understanding, hey, I'm starting at negative 3 and then I'm repeatedly multiplying, where I'm starting at negative 3 then repeatedly adding, the equation writes itself and then I just have to solve an equation. That's how, and then that gives me my common ratio, it gives me my common difference, and then I can apply it to get those means. Does that make sense? What are your questions? Okay, make sure you put your grade on there, date it, put today's date next to it, and let's move on for today. Today would be the 18th. So once again, we got to move quickly today, because if you do not finish the task, then you have extra problems for homework tonight. Oh no. I mean, I assume y'all don't want extra homework, right?
I don't have the time to do it anymore.
So we better get to work. So we're going to look at our objectives and we're going to launch 2.3 linear exponential neither, and you're going to be working within your groups today on this the whole day. We might get a chance, if we have time, everyone finishes up early, wrap up at the end. But we want to be able to identify linear and exponential functions and justify our responses. So one thing I want to point out, what makes a linear function linear? Zay? Ask that please.
Make a straight line.
Only if you're looking at a graph.
No, that's the only way I know.
Adding.
Say again?
Adding.
An additive rate of change. What makes a linear function a line on a graph is the fact that it has an additive rate of change, which you can see the additive rate of change in a table. And in an equation, how do we mathematically show repeated addition? Multiplication. Notice that idea of an additive rate of change permeates every single representation that there is mathematically. And if a linear function has an additive rate of change, what does an exponential function have? Multiplicative rate of change. Those are the defining characteristics of linear versus exponential. And those are similar to the ideas of arithmetic sequences and geometric sequences, but there's one key difference. I'm going to try to talk about that within your small groups, but we need to be able to identify those linear and exponential functions. That is foundational, but then some of us also need to work on understanding whether it's continuous or discrete and the idea of domain. That's what I started to see. Okay, I think most groups, last time we worked, got to number 6. Is that fair to say?
Probably.
Probably, okay. And this is a discussion point that I want to go ahead and get out of the way so that everyone's clear on this. Person's height as a function of a person's age. Linear, exponential, or neither?
Neither.
Okay, why?
Because
most
you
people
stop
stop growing in
growing.
your teenage years. No.
What were you saying, Caroline?
I said what Gavin said. You just
Okay, so y'all have the same idea?
Yeah.
And this is something I do want y'all to think about. First off, and I think it was with Alan that I was talking about this on Monday. When someone is born, they do already have some height to them. I think most babies are somewhere around 1.5 feet tall when they're born. Somewhere around there. So 1, 2, 3, 4, 6, 7. So 1.5 feet. And then they're going to grow very slowly for a little bit. Which I'm just making up age. But then once they get to be about 4 or 5, don't they kind of shoot up a little bit?
A little bit.
A little bit, and then they kind of flatten out for a while, and then they might shoot up again, depending on whether they're a boy or girl. Girls usually hit growth spurts around, I think, 7th or 8th grade, maybe? Is that right? No, 5th or 6th? 5th to 8th grade, whereas guys usually hit their growth spurt somewhere around junior year of high school through freshman, sophomore year of college, unless you're me and then you just never hit another growth spurt, it's fine. But eventually you hit your growth spurt and then you level off, right?
And then you start to shrink when you get old.
Yeah, when you get really old, your bones start to compact. And so regardless though, does that look linear?
Yeah.
I mean, it has some linear pieces to it, but does it look like a line? Not like a single line. Does it look exponential?
It looks like your heartbeat line.
That's a little bit different. It does have some sharp, jagged things in there. But notice that's a justification. I created a graphical representation of what would actually happen. Could you make up a potential table of what someone's height might look like over time?
Possibly.
Possibly. Would that be 2 justifications for why it is neither?
Yes.
Yes. Because then you can say, hey, there's no common difference, there's no common ratio, things like that. So we want to keep these ideas in mind. Did everyone, oh yeah, this is a good one. Did everyone get to 7 as well?
Yes.
Y'all did not? Yes?
We skipped.
I did.
No? Okay, so let's talk about this one quickly because this one is one that usually causes students some trouble, and then I will release you into your groups. Do y'all think this number 7 would be linear, exponential, or neither?
Linear.
Why do you think it's linear?
Because you're adding.
How do you know you're adding?
Because it has a plus on.
So this plus right here?
Sure. Mm-hmm.
So let me ask you this question though. A
No.
linear function has what type of rate of change?
Common.
And
Additive. But
I don't know.
if it is a common, it's called a common difference, right? An additive rate of change is a common difference. But if it's an additive rate of change, is it adding one time or is it repeatedly adding?
repeatedly.
Repeatedly adding. Is that being repeatedly added?
No, it's just one.
That 7 is only happening one time. And this is a key thing that I need students to recognize, I need you to recognize. That plus 7 does not make it linear. However, is it linear?
Yes.
It actually is. Because of the multiplication. Notice I am multiplying right here, so that is repeated addition. And I am multiplying right here, so that is also repeated addition. This has some kind of additive rate of change. Right? And so why? Multiplication is repeated addition. So there is an additive rate of change. Now, is that enough reasons?
Yes. Yes, sir.
Is it?
I think so.
Yes.
Sold me.
Give at least 2.
Oh,
I
man.
need one more.
That ain't on our paper.
Huh?
Is that?
So that's good.
What? No what?
Give 2 reasons.
It is on the paper. If you look at the very first problem before the very
I don't see
first
it.
one.
I don't see it.
Yeah, I don't see it.
The directions there?
I think I misplaced it.
Is it there?
I'm blind.
Yeah, it's there. Okay. So,
Worked out.
but here's the thing. You're complaining instead of just listening. Look, I've used justification. I've used verbal reasoning here. What other mathematical representations are there?
Table.
Tables.
Equation.
Well, I have an
I
equation.
did a table.
Because you have made a table here and found some points.
Chart.
Yes.
Okay? I will say, like, this is designed to be tackled before students have learned how to solve equations, but if this is linear, could I solve it to get into y equals mx plus b? And figure out what that rate of change is?
Mm-hmm.
Did you know that your calculator can actually graph it looking just like this?
I learned that yesterday.
I knew that.
So there are different ways to approach this. I'm just saying, like, you need to do something else. For example, if I plug in, I don't know, if you're thinking about a table, it would be a little hard just because of the way this is set up. But you could plug in a 0 for x and figure out what y would need to be.
-7. What? Okay.
Right? You gotta divide by that 4, so -7/4.
Sure.
But there's multiple ways to approach it. You just need to make sure that you're paying attention to different details, but it would be linear. So, within your groups, go ahead and start here at number 8. We need to be knocking this out quickly and efficiently and getting as far as we can before the end of class. Go ahead and start talking with each other, starting on number 8 or wherever you left off. Talk through the ideas of linear and exponential. Notice that we want to think about different representations, and we need to remember what makes something linear and what makes something exponential. So talk through those defining characteristics.
One's number 9.
Keep your head up there.
Right.